Okay, welcome back. We're going to calculate to figure out how much money there will be in an account after a given number of years, and also the interest earned on that amount. So let's write down the given information with this problem. Okay, so let's find how much money there will be in the account after a number of years. Okay, so we are going to be given a principal of, let me just write that, 15,000. The rate, I'm just going to convert it to decimal form. All right, which is going to be 0.05, which would be 5%. And then time is going to equal 3 years. In this particular situation, the interest is compounded annually, so we're going to use the following formula. Okay, so A is the future amount, P is the principal, R is the rate, T is in time, which will be the case in all these formulas. All right, let's plug in our values. Principal is 15,000. The rate is 0.05. We're going to raise that to the third power. Okay, so 1 plus 0.05. Okay, it's just going to be 1.05, raise that to the third power. Okay, and if you raise 1.05 to the third power first, then multiply by 15,000, you will get a value of $17,364.38. Okay, so that is the first part. The second part is we're going to find the interest earned on this amount. So we are going to, all you have to do is, this future amount is $17,364.38. Okay, you would just basically take the difference of the principal in that amount. So what you do is you have, $17,364.38, and you're going to subtract the original principal, which is going to be 15,000. And when you do that, you get a difference of $2,364.38. Okay, so that's all you really have to do. Right? Use that formula and then take the difference of the future amount with an original principal, and you will get the interest earned, which is about, almost a little over $2,300, which makes sense because you're starting off with 15,000 and then you add $2,364.38. You should get the value we calculated initially, $17,364.38. Okay, so now we are going to find, oh, by the way, this was compounded annually, so let me just write that down. Okay, this is given, by the way, so it's going to be compounded annually. Okay, so in this particular problem, or problems, you've got to look at how many times the interest is compounded. Okay, so which will be how many times the interest will be tacked onto the principal. So in this case, it's every year. And each problem is going to be different. They'll give you semi-annual, monthly, daily, etc., etc. We're going to do one where it's compounded semi-annually. So it's going to be compounded semi-annually. Okay, and the given information is going to be principal is 7,000. The interest rate, if we convert that to a decimal, it's going to be 7%. So if we convert that to a decimal, it'll be 0.07. And the time is going to be 6 years. So now we use this particular formula. Okay. If it's compounded more than once a year, then we need to use the following formula to get the future amount. So depending on the situation will depend on the formula you'll use. That's the trend here. Now it's just a matter of plugging everything in and calculating or crunching through the numbers. All right, so we said that's 7,000. The rate is 0.07 divided by, n is going to be 6. Or no, 2, because it's compounded annually. So n is the number of times it's compounded. In the previous problem, n should equal 1. Okay? But there's no n in this formula, but I'm just telling you, how many times it's compounded. But if it's compounded annually, we have to use this formula. And the next formula, more than once a year, we use this one, and that's when the n factor takes into account, because that tells you how many times per year it's being compounded. So n has to be 2. Okay? So we're going to plug in 2, and then we're going to do 2 times 0.07, because it's n times t. Okay? Alright, so we have 7,000 times, now what we're going to do is we're going to do 0.07 divided by 2, and then we're going to add 1 to it. All right, so do the division first, okay? Do 0.07 divided by 2, you'll get a number, then add 1, and then you're going to get 1.035. And you're going to raise that to 2. I forgot to put time. Okay, it's not 2 times the rate, it's 2 times the time. It's the n times t, not n times r, so I apologize for that. So C is going to be 6 years. Okay? And then 2 times 6 is going to be 12. So you raise that to the 12th power. Okay? So n is going to be 2. The time is going to be 6 years, so it's 2 times 6. The rate is 0.07. Okay, and the principal 7,000. All right. So when you do 1.03 raised to the 12th power and multiply it by 7,000, you should get a value of $10,577.48. Okay, and that's all you have to do for that. For the first part. The second part, I want you to find the interest earned. Remember we did that in the previous problem? So you take your original, the future value that we have, okay, which is $10,577.48, and we're going to take the difference of the original principal, which is 7,000. And when you do that, you should get $3,577.48. $3.48. So if you take the difference of these two, you get that value. So that's how much interest earned on that amount after 6 years. So $7,000 plus $3,577.48 will give you the $10,577.48, which makes sense, right? Okay, so now if you do this quarterly, let's say you want to compound it quarterly, well, there are 4 quarters in a year, that's every 3 months, so you would do n would be assigned to 4. Okay? If it's monthly, then you do, there are 12 months in a year, so you would basically do n would be 12. So it'll be the rate over 12 when you plug it into this formula. See the r and the n? All right, the rate's going to stay the same, but n needs to be 12 in that case. So the process is the same thing. You use the same formula. You just have to look at what n is, right? And that's going to change. If it's daily, then you do 360. N is 360 because there are 360 days. Now remember, they're rounding the months that are 31 days to 30. So we're just going to say 30 days, all right, for each month, times 12 is 360 days. So you would do the rate, which is whatever the rate is, and then you divide that by 360. N has to be 360. All right, same formula, same process, just different numbers. Okay? Now, another situation you're going to run into is when you're going to be given 2 rates, all right, with 2 different situations of how it's compounded. Okay, one's going to be compounded daily, the other one's going to be compounded continuously. All right, so we're going to find the amount due if the interest rate is 11% compounded daily. The principal is $10,000. So all this information is going to be given. So let me write that down. All right, so the first part is the principal is going to be $10,000. All right, and that correlates to a rate of 11%. So that's just going to be 0.11. Okay, and in this situation, it's compounded daily. So n is going to be 360. Now in this case, they're not rounding the months off. They want you to use the full amount of years, which is 365. And how you can tell which one to use is that they will tell you. In the previous problems, it says assume 1 year is 360 days. When you see that, then you use the 360. If they don't mention that, then you use 365. So that's how you can tell what number to use for n. So a little FYI. All right. So n has to be 365. Now we're going to use the following formula, which is what we used before. We're going to have the principal times 1 plus the rate over the amount of times it's compounded times nt. Now it's a matter of plugging everything in like we did before and calculate. N is going to be what? 365. And then it's going to be n times 3. So we do 365 times... time is given as 1 year. Okay, I forgot to give you that information, 1 year. So it's going to be 365 times 1. All right, so the principal's given, the rate is going to be given, the amount of times it's compounded will be given, and the time will be given. All that information will be given. You just have to figure out what n is based on the amount of time it's being compounded. So when you do 1 plus, I'm assuming you know how to do the arithmetic behind this, right? You do 0.11 divided by 365, you add 1, okay, and you will get the following number. Okay, then you take that number 1.000300137, raise that to the 365th power, and multiply that by 10,000, and you will get future value of $11,162.60. Now we want to use the other rate. Okay, now we want to find the amount due if the interest rate is 10.88% compounded continuously. All right, let's do that on the next slide. So now the principal is still going to be 10,000. The rate is going to be 10.88%. If you convert that to a decimal, you'll get 0.1088 compounded continuously. Okay, I'll just write this info down. So n is going to be, well, actually, we don't need n in this situation, because when it's compounded continuously, we use an entirely different formula. All right, and we're going to use this one. Okay, P times e to the nt. All right, the e means that we are using that formula when it's compounded continuously. Now we just plug in the information. Principal is 10,000 times nt. Now what do I say n? R is going to be the rate, so it's going to be 0.1088, and then we times it by, this is also going to be compounded as 1 year as well, okay? So okay. I don't even know why I need I should just read e to the 0.1088. Now when you do this on the calculator, 1 times 0.1088 is going to be that value, that same value, 0.1088. So in order to do this on a calculator, if you have an iPhone, you can do it right on the iPhone, right? If you press the calculator app, right? Then you tilt your phone horizontally, it turns into a basic scientific calculator. And basically you enter the 0.1088 value, the rate, okay, whatever you get when you do R times T. You type in that number first, and then on the calculator you should see the e to the x function, okay, which will be, you will see it, it's the 5th column from the left, second button down. It'll be under the m minus, and it'll be e to the x, and then you'll get the value, okay, and then you times that by 10,000. So let me give you that value so that you have it, or you can see it rather. Okay, so type in 0.1088 and then type hit e to the x, okay, and you're going to get this. Okay, 1.114939, etc. Use every single number that you see on the calculator, so you get a very accurate. Don't round anything, okay? Just whatever. You're going to get like probably a 15-digit number, something around there, and then you times it by 10,000, and then you will get the following value. So just give me one moment while I calculate that for you. Okay, you're going to get A equals 11,149 dollars and 39 cents. Okay, now we compare the calculations and see which one is the better value. Okay, and basically, since $11,149.39 is greater than $11,149.39, the rate of 11% compounded daily yields the larger amount after 1 year. So remember, the first calculation was $11,162.60 when that was compounded daily. Okay, and then when it's compounded continuously, you get $11,149.39. Okay, so when it's compounded daily, you will get a little bit more. Okay, not tremendously, but more. So that would be the better investment. Okay, because if you have a larger amount of money as the principal, that's when the difference becomes greater. Okay, so something to keep in mind. Pay attention to how the money is being compounded, and that will determine what formula to use. Continuously, you're always going to use E. And people are probably asking, well, what is E? Why do we, what does that even mean? All right, well, it's kind of mathy. It's basically known as the Euler's number, okay, which is a mathematician. It was named after a mathematician, okay, and it's basically a mathematical constant, approximately. It's a constant that's approximately 2.71. 1828. And it can be characterized in many ways, and it is the base of a natural logarithm. Okay, so when you have equations with natural logarithms, okay, and you take the natural log on both sides, you can eliminate the E value, and the equation becomes a lot easier to solve. All right, and in calculus terms, it is the limit of so let me write this down. E is the base of a natural logarithm. Okay, and if you studied logarithms before, you will understand the basic concept of them and know how to solve equations that contain them. Okay, for example, it's a system based on 10. So let's say an earthquake is like 7.0, and you want to know how much stronger the 8.0 earthquake is. You would use a formula that would have a logarithm, and since it's based on 10, it'll be much higher than 7.0. It'll tell you the force, how much force that's greater than 7.0 and 8.0, and it's usually a tremendous amount, you know, like 1,000 times, 10,000 times, etc. So there is practical use of this number, okay? And in calculus, it approaches infinity. It's the limit of 1 plus 1 over n raised to the n power as it approaches infinity. And this expression arises in the study of compound interest, which is kind of what we did, right, recently? Okay? So, again, this is not related to this problem. Well, it kind of is, but that's the meaning of the E value. Anyways, a little history lesson for you with that. Okay? Okay, now let's do another problem where we're going to use a different formula. And let's say you have, you want to know how much money should be deposited today in an account that earns 4% interest compounded annually so that it will accumulate to $16,000 in 3 years. So you want to know how much, you want to calculate the original principal in order to get to a future value of $16,000 based on the interest rate of 4%. And when you have that situation, you are going to use the following formula. So, you know, you want to find P, which is the principal, and the rate is going to be 4%, so it's 0.04. And it's going to be compounded semi-annually, so I'm just going to write n equals 2, okay? So I'm assuming you know what n means by now. It's the amount of times it's compounded, which represents the letter n. Semi-annually would mean n is 2, okay? And the future value is going to be $16,000. All right, so you want to go from what do you need originally, all right, to get to a future amount which is given. All right, and you need to use the following formula. Okay. P equals A divided by 1 plus R over N raised to the NT power. All right. Okay, so again, we know the information. Why don't we just start plugging it in? All right, so A is going to be 16,000. It's going to be 1 plus 0.04 divided by 2, and N times T. Oh, by the way, T is going to be given in 3 years. I forgot to give you that information. T is 3 years. I always forget the time. I don't know why. This is given. T is going to be 3 years. So we don't know how much interest is going to accumulate in that amount of time. So when you do N is going to be 2 times 3. Okay? So a little simplification here. Okay? When you do 0.04 divided by 2 plus 1, all right, you will get 1.02, and you're going to raise that to the 6th power because 2 times 3 is 6. All right, and when you do this calculation, do 1.02 to the 6th power first. You will get a number, which I can do right now for you. Okay, you'll get that number, 1.12616, etc., etc. Leave the entire number in the calculator that you get. Okay, so you do 1,600 divided by that number, and you're going to get a value of $14,207.55. Okay, so, and round it to the nearest cent, and you get 55 cents. So therefore, $14,207.55 should be deposited today at a rate of 4% compounded semi-annually in order for it to accumulate up to $16,000 in 3 years. All right. So that's how you do that kind of situation. Okay, so we're going to look at another situation where we're going to calculate the annual yield. We're going to determine the effective annual yield for each investment. All right, we're going to have more than one investment, and then we're going to select the better investment. We're going to assume, again, rounded each month at 30 days, 360 days in a year, at a rate of 15% compounded monthly, and the other one is compounded at 15.25% compounded annually. All right, so let's go ahead and calculate that. Now the formula you need, okay, is the effective annual yield formula. Okay, let's write down some information. Okay, so the effective annual yield is going to be a question mark. We don't know that. The rate, let me convert that to, we're going to do the one that is 15%. So it's going to be 0.15 compounded monthly. So N is going to be 12. Okay. And now we can plug in the formula. We can use the following formula. The effective annual yield equals 1 plus R over N raised to the N power minus 1. Okay, we need to substitute everything that's given. All right, and then now, all right, so if we do 0.15 divided by 12 plus 1, let's see what we get. Let me go ahead and calculate this for you, just a moment. Okay, so you're going to get 1.0125. Going to raise that to the 12th power. And you're going to get y equals 1.16075. We're going to round this to the nearest cent, okay? So we look at the, hold on just a moment. All right, so when you do 1.16075, subtract 1, you get 0.16075. You can just drop the 1 and the decimal part is remaining. Just skip that step. And then we're going to convert that to a decimal. So we move it over 2 places, and now we're going to get y equals 16.0. Now if we round this to the nearest cent, we look at the number to the right of 0, because you got 16 point, let me do it down here, 16.05. So the place value is the second digit, which is the hundreds place. The number to the right is 5 or more. So the 5 becomes a 0, and you no longer need it. We're going to add 1 to the 7, and you get that. Okay, 16.08%. And then now if you want to calculate the other one at 15.25%, we are going to do this one. Okay, now in this particular case, this is going to be compounded annually, so N is 1. So in that case, if N is 1, if it's compounded annually at a 15.25%, okay, then the value of N is 1, so therefore at a 15.25% rate, that's going to be equal to the rate, right? Because every year it's 1.1525%. Okay, so since the interest is compounded annually in this investment, the effective annual yield is going to be 15.25%. It's the same thing. Okay, so the effective annual yield for the first investment is 16.08%, which we just calculated. Okay, that's this value here. And if 1 year equals 15.25%, which is this value, then the effective annual yield for the second investment is 15.25%, and the first investment is 15% compounded monthly, is the better investment because the effective annual yield for the first investment is higher than the effective annual yield for the second. Okay, so the first one we did was 16.08, and that was compounded, what do you call it? Monthly, okay? So you get a higher percentage rate than the 15.25%. All right, so that's how you do something like that. You just calculate the annual yield for both rates, and in both compounded situations, you know the end values, and then you compare which one is the highest one to give you the better rate. Okay, so that is how you would do that. So it's not too hard. Okay, you just got to follow the formula.